The universe has still many secrets that we have to unlock. And in order to unlock these secrets, we need to reach even higher levels of energy. CERN was created in 1954 with the primary mission of advancing research in physics to understand why the universe exists and why it looks the way it does. The LHC, the Large Hadron Collider, is the biggest and most complex machine ever built. It is 27 kilometers long and about 100 meters underground, and crossing the border between France and Switzerland. Inside the accelerator, two beams of high-energy particles run close to the speed of light and hit each other in 4 points where the experiments have their detectors.
Behind, I have the CMS experiment, which is one of the 4 main experiments in the LHC accelerator. And here the collisions are made.
Where the collisions take place, the conditions which took place shortly after the Big Bang are recreated, and we take information from the experiments like Alice here to help scientists better understand and give insights about the laws of nature.
By recording the trajectories of all the particles smashing against each other in the accelerator, we produce a huge amount of data that have to be collected, analyzed, and stored.
The challenges are very big, and we have to work with a number of technological partners.
In 1982, CERN came with a challenge of dealing with 200 megabytes of data. And currently they are coping with a volume of data which is reaching 50 petabytes per year.
In the data center here at CERN, we store over 200 petabytes of data. This is equivalent to about 2,000 years worth of high-definition video.
Thanks to this data, it has been possible to actually discover the Higgs boson in 2012.
The Higgs boson was the last missing piece in the puzzle of what is called the standard model of physics.
The Higgs boson is the particle that gives mass to every other particle. Without the Higgs boson, nothing would exist. The Higgs boson was the last missing piece of what is known as the standard model of physics. But this model describes only 5% of the universe as we see today. The next big objective is to understand what 95% of the universe around us is made of.
We're now excited to investigate what lies beyond the standard model of physics and explore phenomena such as dark energy and dark matter.
And in the coming years, we will have to understand how this dark matter and dark energy actually works with the instruments we built here at CERN.
Planned upgrades mean that in the next decade we'll be able to collide particles at greater rates than ever before, producing more data to help us explore the unknown.
The technology produced by Oracle in databases and more recently cloud computing is essential to be able to scale out our operations to the levels that worldwide physics research requires today. CERN is a place really at the forefront of technology. The World Wide Web was invented here at CERN, and the primary reason was to improve collaboration among scientists, and the result is what we see in the World Wide Web today. Accelerator technology used for physics research has been transferred to hospitals and medical research laboratories to help fight cancer. So much innovation and so many new discoveries are made in this kind of international collaborative environment that has no other equivalent in the world.